Assalamu alaikum guys, my name is Ikhlaq Yusuf Malik, and in this video we are going to talk about the binary search. Basically, how does it work, what is it, and what is movements and how to code it. So let me create a first file, binary search.example.java, and after that I'm going to create its main method. Okay, then after that let me declare an array. I'm going to declare an array. So I'm going to put the elements in it. Basically, the binary search works on the sorted array. So let me store the sorted array elements in it in the array variable. So after that, what I'm going to do, I'm going to make a uh, static function which is going to return basically an index of an element if it founds it, and if not, it is going to return -1. So I'm going to name it as binary search algo. So which is going to basically take the two parameters. One is the array and another is the number to be found. So I have declared those variables. So what I'm going to do it after that. So let me first close this left side screen, and if I'm not going to able to find, I'm going to return -1. So I have returned -1 from the function. So what basically the binary search is work uh, basically we divide the array half at every iteration, so every iteration. So let me first store the left pointer variable, and I'm going to store the 0th index, and after that I'm going to make the right pointer, which I'm going to assign the array dot length -1. So basically this is going to be a total array. So I'm going to play with this left pointer and right pointer. So what I'm going to do basically, after every iteration, I'm going to divide the array by half. So I have to write left pointer is less than or equal to right pointer. So I have to do the iterations while this condition until this condition is satisfying. Okay, so what now I'm going to do, basically I'm going to calculate the middle index of that array. So for that I have created an integer variable int mid pointer is equal to, so that is going to be left pointer plus right pointer divided by 2. Okay, so what basically here we are doing, that we are saying, suppose if the number is greater than this element that is at the mid index, we are going to compare it basically with that. If it is less than, then we have to look to the left side of that left side of array. If it is greater than, then I will have to look at the right side of an array. So I'm going to write those functions like if the number that we have supplied to this function, if it is less than the mid pointer, whatever is in the at the mid index, so we are going to compare it with that. And else if it is greater than the element at the mid pointer, so I'm going to basically upload this left pointer and right pointer till we can find that element. Okay, so I'm going to update this. So if I'm going to write that like I'm going to check this if its number is greater than array mid pointer, and else we have find the element. Like if it is not greater than, it is not less than, then it is equal, so we have found the element. So now we have to update those pointers, like if it is less than. So what if it is less than, then I have to move that right pointer to the mid index. Okay, so I'm going to write like right pointer. So I'm going to write right pointer is equal to mid pointer -1. Okay, so now I have to, if it is less than, then I have to search that element from the left side of the array. Okay, so that is what I have wrote. And if it is greater than, then I have to shift the left pointer to the mid index. So this is going to be repeated until left pointer is less or equal to right pointer. Okay, so I have assigned the left pointer value to the mid pointer +1. So else if it's not less than, it's not greater than, then we have found that element, so we are going to return this index. So that is how the binary search works. So basically what we are doing, we are dividing at every iteration, we are dividing the array to its half of the size. Okay, so that is going to make its complexity to n log n. So yeah, now uh, I have got the function. Now I'm going to call it. So basically let me write the printing statement system.out.println, and then I'm going to call that function binary search algo, and I'm going to pass this array that I have created, and I'm going to pass any integer value, like the element that is in present, or I can pass any value if I were to check if this number is present in an array or not. Okay, so it should me print me 0 1. It should print the 1 index if it, because it is in the because it is the first position. So now I'm going to supply any argument that is not present in an array, so it should give me -1. Suppose 0 is not present in array, and it's going to be give me a -1. Yes, it has clearly given. Suppose if I am going to place any other value, it's going to give me the index of that. So basically the array index starts from 0 to the length -1. So that is why it is 1 less than. So yeah, it has given me 4 if I have supplied the 8 place. So now I'm going to clear that. Now let me quickly explain it again. So basically what we are doing is we are maintaining the left pointer and the right pointer value, and at every iteration we are dividing our array divided to half. So if array is if a number is less than array, so we are going to basically we have to number is less than array ka mid pointer, so we have to find it element in the left half. Okay, if it is greater than, then I have to put a right half. So this we are going to continue this process until we find our number. So if it is not going to meet these conditions, we are going to return -1. So that is all. Thank you guys. Like and subscribe.